The solid potassium permanganate is violet in color and its aqueous solution is purple in color. And the color is due to charge transfer. Potassium permanganate, solid, when you heat it, you get potassium manganate, manganese dioxide, and oxygen. Potassium permanganate is a strong oxidizing agent because manganese is its highest oxidation state +10. The product of the manganese permanganate depends on the condition of the medium. If the medium is acidic, in H plus medium, permanganate changes to manganese 2 plus, which is almost colorless. And remember, high spin D5. Example is manganese 2 plus, iron 3 plus, should be colorless, almost colorless. If you see color of iron ferric chloride is not due to DD transition, is due to charge transfer. Yellow color of ferric chloride is due to charge transfer. In water or dilute alkali, permanganate changes to manganese dioxide. And in strongly alkaline condition, permanganate changes to manganese. So, in acid, you will get almost colorless solution. In neutral medium, you will get a precipitate of manganese dioxide, which is a brown, black color, and in strongly alkaline medium, the permanganate will change to manganate, which is green in color. So the purple will change to green color in strongly alkaline condition. Permanganate will oxidize ferrous to ferric and get reduced to manganese 2 plus. And this electron is a 5 electron change. +7 going to +2, it's a 5 electron change. This is a 1 electron change. So the mole ratio will be, you have to equal the number of electrons, so it will be 5 moles of ferrous will give me 5 moles of ferric, and you need 4 moles of water. In a permanganate will oxidize iodide to iodine, and permanganate will reduce to Mn2 plus. So when I write permanganate plus iodide plus acid, I get manganese 2 plus iodine plus water. Now in order to get iodine, I2, I have to start with 2Y. Okay? So it is a 2 electron change. It releases 2 electrons. Permanganate to manganese accepts 5 electrons to get reduced from +7 to +2. So, 2 permanganate, 10 moles of iodide, give me 2 moles of manganese dioxide. You cross multiply. You multiply 2 by for permanganate and 5 into 2 for iodide. So I get 5 moles of iodine. Okay? 2 moles of iodine will give me 1 mole of iodine, which releases 2 electrons. And permanganate requires 5 electrons to get reduced to manganese 2 plus. Now you cross multiply. So you require 2 permanganate, 10 iodine to give 5 moles of iodine. Now you see the charge of the manganese. 2 into 2, 4 positive charge. Make the left hand side 4 positive. So you have 2 negative and you have 10 negative. So you have to have 16H plus. So you will have 8 water.
Yes.
Okay. Permanganate will oxidize H2S to sulfur. Again 2 electron change. H2O plus sulfur dioxide, that is your sulfurous acid, will get oxidized to sulfuric acid. Again 2 electron change. Permanganate plus oxalate ion plus acid will give me manganese 2 plus carbon dioxide plus water. Now, this to this 5 electron change. Carbon is 3 plus going to 4 plus. So one per carbon 1 electron change. So there are 2 carbon. So 2 oxalate, 1 oxalate will give me 2 carbon dioxide, which involves 2 electron change. You understand? Carbon is 3 positive here. In carbon dioxide it is 4 positive. So per carbon there is 1 electron change. In oxalate there are 2 carbon atoms are there. So total electron change is 2. So it will be same. 2 permanganate, 5 oxalate ion plus H plus will give me 2 manganese 2 plus. Now I will have 10 carbon dioxide. 5 into 2 gives 10 carbon dioxide plus water. Because each carbon is now oxidized from plus 3 to plus 4. So since this is a 2 electron change, I cross multiply. So 2 permanganate, 5 oxalate. Okay? Make the electron change equal. Now again, you see the product has 4 positive charge. You have 2 negative plus 10 negative. 12 negative charge, so it has to be 16H plus, so it will be 8 moles of water. Okay? Permanganate will oxidize thiosulfate to sulfur plus sulfate ion. 1 mole of thiosulfate will change into 1 mole of sulfur and 1 mole of sulfate. Now, thiosulfate is sulfite plus sulfur gives you thiosulfate. So, this sulfite ion gets oxidized to sulfate ion. How many electron change? Sulfur is in plus 4, now going to plus 6. 2 electron change.
Yes.
This permanganate goes to manganese 2 plus, 5 electron change. Okay? So,
Yes.
2 moles moles of permanganate ion, 5 moles of thiosulfate ion plus acid will give me 2 moles of manganese 2 plus 5 sulfur, because I said each thiosulfate will give me 1 mole of sulfur, 1 mole of sulfate. So 5 moles of thiosulfate will give me 5 moles of sulfur, 5 moles of sulfate ion plus water. Remember that the thiosulfate gives me 1 mole of sulfur, 1 mole of sulfite, and 1 mole of sulfite gets oxidized to sulfate ion. So you have 4 positive charge here, you have 10 negative charge here. So what is the overall charge? -6.
6.
You have 2 negative charge here, plus 10 negative charge here. 5 into 2. 10 plus 2, 12. 12. You have 6H plus. Now, permanganate, if you react with ethylene, ethene, in presence of water, it will give you manganese dioxide plus ethylene glycol. It shows an addition reaction. In presence of concentrated sulfuric acid, it will give Mn2O7 and potassium hydrogen sulfate. And this is an explosive oil. Dimanganese heptoxide is an explosive oil. Now we go to potassium dichromate. So the normality of potassium permanganate, it will oxidize, potassium permanganate will oxidize stannous to stannine.
Yes.
Again, it is a 2 electron change.
Yes.
So it will be 2:5. The mole proportion will be 2:5. Yeah. Now, if I take 0.1 mole of ferrous oxalate in presence of sulfuric acid, and I titrate with potassium permanganate, number 1. Number 2, 0.1 mole of stannous oxalate. In sulfuric acid medium, I titrate with potassium permanganate. What will be the volume of permanganate required? I have strength of permanganate is 1 normal. Okay, I give you a hint. For 1 mole, for 1 electron change, you require 1000 cc of 1 normal KMnO4. It's a simple unitary method. For 1 mole For one electron change, you require one equivalent of permanganate, which is equal to 1000 cc of one normal permanganate solution. How many electron change is taking place in this case? How many electrons?
2 electrons.
Why 2?
Oxalate will get converted.
Will not ferrous be getting oxidized to ferric? Iron 2 goes to iron 3. Oxalate goes to carbon dioxide. So how many electrons change?
3.
So why did you say 2? Ferrous is getting oxidized to ferric, oxalate to carbon dioxide. So the electron change is 3. Now you give me the answer. The answer is 300 cc.
Yes.
For one electron change, 1000 cc. 0.1 mole, one electron change is 100 cc. For one mole, 3 electron change is 300 cc.
300 cc.
Oh, okay. If it is 300 cc of one normal, then how many cc of one molar?
1500.
No, it is 60. Because 5 normal is equal to 1 molar. Because it's a 5 electron chain. So 1 molar is equal to 5 normal. So you have to divide by 5 to get the volume in molar in 1 molar solution. What will be the answer for the second one?
400 cc.
400 cc and 80 ml of 1 molar permanganate. Okay. Now, remember, total, it is a both cation and anion are oxidized. Ferrous is going to ferric, oxalate is going to carbon dioxide. So both are oxidized. So you have to see the total number of electron change is 3. In stannous oxalate, stannous going to stannate 2 electron change, oxalate going to carbon dioxide 2 electron change. So the total number of electron change is 4. So you have to use 4 into 100 cc, that is 400 cc. Okay. Second question is, why sulfuric acid and not hydrochloric acid? Why permanganate titration normally is carried out in sulfuric acid medium and not in hydrochloric acid medium? Because permanganate plus HCl gives you KCl, MnCl2, chlorine plus water. Now you understand why HCl is not used? Because permanganate will oxidize HCl to chlorine. So permanganate will not only oxidize ferrous to ferric, it will also oxidize HCl to chlorine. So the titer value will be much higher.
Yes.
Now balance the equation. Can you balance, or I will have to help you? This is what you have to look for. How many chloride ion will be required to get 1 mole of chlorine? 2. So 2Cl minus will give me chlorine plus 2 electrons. So I have to use 2 moles of permanganate.
Yes.
How many moles of HCl?
3 moles.
Not 10.
3.
How many? 16. Okay. So 2 KCl, 2 MnCl2, 5 Cl2, 8 water. Good. So always iodide, chloride, you have to start with 2 iodide, 2 chloride to get chlorine or iodine. Okay? Remember that. So this is the reason why HCl is not used. But you can carry out the reaction. You can follow permanganate titration in HCl medium under special conditions. That is, since permanganate ion is giving me manganese 2 as a product, so if I add manganese sulfate plus phosphoric acid mixture is called Zimmermann-Reinhardt reagent. So before titration with permanganate, if I add excess of manganese sulfate and phosphoric acid, then if you write the half cell of the Nernst equation for this half cell, what will happen? E cell is equal to E0 minus 0.59,
Upon 5.
Yes.
N is here 5 because a 5 electron chain. Now if I add excess of manganese 2 plus, then what will happen? This term will be a large negative value, so E cell will decrease,
Decrease. Yes.
and now permanganate cannot oxidize chloride to chlorine because now the oxidizing character of permanganate has reduced. So simple Nernst equation. If I add manganese sulfate, which is a product of permanganate in acid medium, the E cell changes. So the permanganate oxidizing property of permanganate reduces. As a result, permanganate cannot oxidize HCl to chlorine. So in that case, you can carry out the reaction in HCl medium.
Yes, sir, but what is the need in the necessity of that H3PO4?
H3PO4 forms a complex with the other. If iron is present, forms a ferric phosphate complex and lowers the oxidation potential. So nothing, it is just a complexing agent.
So then we can use any other acid which can take complex.
What?
Means we can also use any other acid for replacing H3PO4. Why do we need that special H3PO4 only?
H3PO4 form, if iron is present, the ferric ion oxidation potential is complex by phosphate ion, not by other ions. That is why we don't use other acids. So remember, if I use permanganate plus sulfur dioxide plus water, what will be the manganese product? What is the value of N? What will be the product of manganese? MnO2. No. Because sulfur dioxide plus water gives sulfurous acid, which ionizes to give H plus and bisulfite ion. And this H plus is strong enough to give manganese 2 plus. So you have to be careful that just because water, don't get carried away by manganese dioxide. You have to see with water whether I can generate acid or not. Sulfur dioxide with water will give you sulfurous acid, which will ionize to give you H plus. So it becomes acidic. So the medium is acidic. So the product is manganese 2 plus and not manganese dioxide. Now we move to potassium dichromate. Potassium dichromate is another very useful oxidizing agent. It's a primary standard. What is meant by primary standard? The compound should be pure and its concentration should not change with time. If these two conditions are satisfied, then the substance is called a primary substance standard. The concentration should be unchanged. That means it will not decompose with time, and it should be analytically pure, 99.9% purity. If both the conditions are satisfied, then it is a primary standard. So you can just weigh the substance and you know its concentration. You know the mole, how many moles you have taken directly from the weight. If you know the volume, you know the molar concentration. Potassium dichromate is prepared from a ore called chromite ore. It is a mixed oxide. FeCr2O4 is called a chromite ore, which is a mixed oxide, FeO plus Cr2O3, chromic oxide. So, chromite ore, if chromite ore is fused means high temperature, in presence of sodium hydroxide and oxygen, what is the change is taking place? Iron is in 2 plus, chromium in 3 plus. Iron is 3 plus, chromium in 6 plus. So iron 2 getting oxidized to iron 3, chromium 3 is oxidized to chromium 6. So what is the total number of electron change? 4. Okay, let me tell you how do you get this 7. Start with 2 moles of FeCr2O4. This gives you Fe2O3. There are 2 iron. So at minimum I start with 2 to get Fe2. This involves how many electron change? Fe2 to Fe3. How many chromium? 4 chromata, Cr6 plus. How many electron change?
12.
So 12 plus 2? 14 electron change. Okay?
Yes.
Who is doing the oxidation? Oxygen? How many electrons?
4.
This is 0. This is 4 minus. Where from the 4 minus comes? Because it accepts 4 electrons.
Yes.
Okay? So cross multiply. Now you cross multiply. 14. 14 electrons. Okay. Good. 14. So 8 FeCl2 will require 14 moles of oxygen. Divide by 2. Divide by 2.
Yes.
Do you get this? Okay?
Yes.
Now why 16 sodium hydroxide? Because from 4 chromite, I will have 8 chromium. 4 into Cl2, 8 chromium. And sodium chromate has Na2CrO4. So each chromate has 2 sodium ions. So 8 chromate will have 16 sodium ions. Who will provide me sodium ion? Sodium hydroxide. So I require 16 sodium hydroxide. Now you got that how?
Yes.
Okay. Have you written?
No, sir.
Have you understood?
Yes.
Oxygen requires 4 oxygen, 4 electrons. Chromite liberates 14 electrons. I cross multiply. That's all. That is another method. Instead of sodium hydroxide, I fused with sodium carbonate. This and this does not change. This and this does not, mole proportion does not change. Because sodium hydroxide or sodium carbonate, they are not oxidizing agent. Oxidizing agent is oxygen. So the number of moles of oxygen will remain same for both cases. If I use sodium hydroxide, the product is water. If I use sodium carbonate, the product is carbon dioxide. That is the only difference. Ferric oxide is a reddish brown solid. The color is charge transfer. Write down. The ferric oxide color is due to charge transfer. Ferric oxide is insoluble in water. Sodium chromate. Sodium chromate is yellow in color. The origin is again charge transfer and it is soluble in water. Now I treat, when I add water, sodium chromate comes into the aqueous medium. So sodium chromate, when I add water, this comes into the aqueous solution of sodium chromate. I add sulfuric acid. Sodium chromate changes to sodium dichromate and becomes orange. So remember, chromate plus acid gives me dichromate, and dichromate in alkali comes to chromate. So chromate in acid converts into dichromate, and dichromate in alkali converts into chromate. So yellow, that is orange. Do you understand now? Chromate in acid changes into dichromate. Dichromate in strong alkali changes to chromate. So when I add sulfuric acid, chromate changes to di plus sodium sulfate. So I need 2 moles of sodium chromate because sodium chromate has 1 chromium. Sodium dichromate has 2 chromium. So I need 2 moles of sodium chromate
Yes.
to give you sodium dichromate, sodium sulfate plus water. Is it clear? So, in order to have 2 chromium, I have to start with 2 moles of sodium chromate because dichromate has 2 chromium. So I start with 2 moles of sodium dichromate. I add sulfuric acid. It changes to dichromate. Sulfate ion combines with sodium ion to form sodium sulfate. Because I have 4 sodium ions from 2 moles of sodium chromate. 2 are there in sodium dichromate and the 2 will be in sodium sulfate. And one of the oxide ion combines with 2H plus to give you water. Now, when I evaporate, on evaporation, first the sodium sulfate crystal will come out, the colorless crystal will precipitate, crystallize, will filter off. When you filter off the sodium sulfate crystal, then on further evaporation, I will get an orange crystal of sodium dichromate. Once I get the orange crystal of sodium dichromate, I dissolve it in water to make a strong solution. So I dissolve solid sodium dichromate in small amount of water. So I get a strong solution of sodium dichromate. And when I add potassium chloride, I get potassium dichromate and sodium chloride. Just double decomposition reaction. When I evaporate, on evaporation, I get first sodium chloride crystal, which crystallizes out first, and then when I further evaporate, I get a reddish orange prismatic crystal. Crystals of potassium dichromate. Now the question may be asked that why potassium dichromate and not sodium dichromate? Sodium dichromate is also oxidizing agent, potassium dichromate is also oxidizing agent. Then why I want to prepare potassium dichromate and not sodium dichromate? Because sodium dichromate is hygroscopic, whereas potassium dichromate is not hygroscopic. So, sodium dichromate is hygroscopic. It absorbs moisture from the air, whereas potassium dichromate does not absorb moisture. So its concentration does not change with time. So potassium dichromate is the primary standard, not sodium dichromate. That is why potassium dichromate is more useful than sodium dichromate.
Excuse me, sir. Sir, and why not in the first reaction only, why not directly K2CO3 potassium carbonate is used in the first reaction with the chromite ore?
I can't hear you properly. Can you speak properly?
So why not directly potassium carbonate is used with the chromite ore?
You can use, but potassium carbonate is, I have to have discussed it earlier that potassium carbonate is more difficult to prepare. You have to use Leblanc's process for potassium dichromate preparation. Sodium carbonate is more readily available than potassium carbonate. It is much cheaper.
Yes.
When acts as an oxidizing agent, it always goes to chromium 3 plus. There is no other oxidation state, only chromium 3 plus. So how many electron change? Total electron change you have to tell me. 6 electron change.
6 electrons.
So the equivalent weight is equal to molecular weight by 6. Whereas permanganate in acid, molecular weight by 5.
Yes.
Whereas dichromate is molecular weight by 6.
6.
Potassium dichromate on heating. Solid potassium dichromate on heating gives potassium chromate, chromic oxide, and oxygen. But ammonium dichromate on heating gives nitrogen, chromic oxide plus water. This is a very, very important reaction. This reaction is called green volcano reaction. What happens that when you heat, dichromate is an oxidizing agent. It cannot oxidize potassium plus to K2 plus. Is it possible? No. Because potassium ion attains the inert gas configuration. To break the inert gas configuration is very difficult. But ammonium ion, the nitrogen is 3 minus. It can be oxidized to nitrogen 0. Because dichromate is an oxidizing agent, it can oxidize ammonium ion to nitrogen. So you get nitrogen as a gas, chromic oxide is a solid. This comes out in the form of gas because the heat is evolved. And it throws the green chromic oxide, which is green colored, into air. That is why it's called green volcano reaction. The nitrogen gas carries chromic oxide into the air, so it throws chromic oxide into the air, and that is why it's called the green volcano reaction. So ammonium ion can be oxidized, but not potassium ion. That is why the products are different. The reactions of potassium dichromate and potassium permanganate in acid medium is the same. It will oxidize ferrous to ferric, iodide to iodine, H2S to sulfur, stannous to stannic. All the reactions are common. Thiosulfate to sulfur and sulfate. But potassium dichromate gives an interesting reaction for detection of hydrogen peroxide. In solution. Hydrogen peroxide, sulfuric acid, both are colorless. Potassium dichromate is orange color. If hydrogen peroxide is there, it gives you the blue color. The color of the solution changes to blue, orange to blue. So if dichromate changes to blue, that means it is hydrogen peroxide is present in the solution. It forms a bis peroxo-oxo complex. This is a peroxo. This is peroxo. 2 peroxo are there. So bis peroxo-oxo complex of chromium 6. So again, the color is due to what? Chromium 6 is missing. So what is the origin of color? Charge transfer. Okay. The blue solution on standing changes to green plus oxygen, and green is chromium 3. So the complex decomposes on standing to chromium 3 and oxygen is evolved. So if I have a blue color from potassium dichromate in presence of sulfuric acid, I will know that the hydrogen peroxide is present in the solution. That is a characteristic test for hydrogen peroxide. Potassium dichromate can be used also to detect the presence of ionic chloride. If a ionic chloride is present, the potassium dichromate not covalent chloride. Mercury chloride will not give this test. Stannic chloride will not give this test. Lead chloride will not give this test. Okay? Only when the ionic chloride is present, this is called chromyl chloride test. When you pass the vapor into sodium hydroxide solution, it becomes yellow due to formation of sodium chromate. Chromyl chloride converts into sodium chromate, sodium chloride, and water. And sodium chromate is yellow. When I acidify with acetic acid and I add lead acetate, you know the formula of acetic acid? Okay? Which we ionize in the form of HOAC. AC means CH3 group, CH3CO. Okay. So when I add acetic acid and lead acetate, I get lead chromate precipitate, yellow precipitate. That confirms the presence of chloride ion. If chloride ion, ionic chloride is present, when you heat it with potassium dichromate with sulfuric acid, it will give a red vapor of chromyl chloride. Chromyl chloride will hydrolyze to chromate, sodium chromate in alkali. And sodium chromate will also have some sodium hydroxide solution because I am passing the gas into sodium hydroxide. I neutralize sodium hydroxide by acetic acid. Now why I don't neutralize by sulfuric acid? Why I used acetic acid to neutralize sodium hydroxide? Just few minutes back I have written that chromate in sulfuric acid changes to dichromate. I don't want chromate to be changed to dichromate. That is why I use acetic acid and not sulfuric acid. And then lead acetate, when I add, what is the formula of lead acetate? I taught you sugar of lead is lead acetate. So when I add lead acetate, the chromate gives a yellow precipitate of lead chromate. And that is a characteristic test for chloride ion. And if bromide or iodide is present, what will happen? The bromide or iodide with concentrated sulfuric acid will change into bromine or iodine. Concentrated sulfuric acid will oxidize bromide to bromine, iodide to iodine. But concentrated sulfuric acid cannot oxidize chloride to chlorine. So it gets converted to chromyl chloride. So bromide and iodide will not interfere in the reaction. Okay?
Sir, then why is reaction with NaOH and acetate used? If at the very first stage only bromide and iodide do not take participation. So the test should end at the first step only.
Can you just shift the? I cannot see the ball. Yeah.
Sir, why do we need three procedures? Means afterwards we are reacting with NaOH also and then acetate also. So if in the very first reaction only, if other than chloride, bromide and iodide form molecules, then why should the reaction have three steps?
These steps are for the detection of chloride. I said whether the bromide or iodide will interfere in this reaction. The test for chloride, no, because bromide or iodide will not form chromyl bromide or chromyl iodide. They will form bromine and iodine. So it will not interfere for the detection of chloride by chromyl chloride test. So chromyl chloride test is a confirmatory test for detection of chloride ion. Now we will start with new element, that is boron, which is very important. Every year the JE, they are asking questions from boron. Okay, so boron is very important from your exam point of view. Boron has many special properties which differs from the other elements of the same group. Boron shows allotropy. Amorphous boron and crystalline boron. Amorphous boron is brown powder, crystalline boron is black. Amorphous, since it is powder, so it has a greater surface area, so it will be more reactive than the crystalline boron. So it is more reactive. Amorphous boron is more reactive than crystalline boron because it has a greater surface area. The minerals of boron is borax. Sources of boron in nature. So boron is not found in plenty in nature. In earth crust you will find boron in the form of borax, which is, we write as Na2B4O7. Actually this is a molecular formula, not the structural formula. When I discuss borax, I will show you what is the actual correct structural formula for borax. Carnite, Na2B4O7 with 4 moles of water. And colemanite is Ca2B6O11 with 5 moles of water.